Coming up, images from a black hole, commercial crew updates, and I have an incredible interview with Lisa Taji about Cassini. Stay tuned. Tomorrow begins right now.
Good morning. How's everything up in the sky?
Welcome to Tomorrow, Orbit 10, Episode 15. I'm Carrie Ann, and with me I have a Jared and a Mike, and actually I've got a whole lot of people. It's almost too many to name. We do have a Dutta, Dutta makes all of the things possible. So there's that. And other people who make all of the things possible are our Patreon members. Of course, I want to give a huge shout out to our Escape Velocity members. These are the people who have donated given us $10 or more to this particular segment of this particular episode. If you would also like to contribute to make all of the things possible, including the pushing of the buttons, head on over to patreon.com/TMRO. Oh my goodness gracious. Okay, we have a lot of stuff to get to.
Yes.
So many things. This is going to be an amazing show.
All of the things.
All of the things. One of the things that we want to make sure that we get to first are launches, and there were plenty of them. So we put Mike on this because he talks very fast. So, Mike, are you ready?
Launches lightning round? Oh my goodness.
We
had three launches this week. We had 3 launches this week, the first of which was an Atlas V launch, which happened on Tuesday, April 18th. Excuse me, let's check out the footage.
2, go for main engine start. 1, 0, and liftoff of the Atlas V rocket with Cygnus and the SS John Glenn, extending the research legacy for living and working in space.
So this launch happened at 15:11 Coordinated Universal Time from Cape Canaveral, and as the announcer said, the payload was the OA-7 Cygnus resupply freighter dubbed the SS John Glenn, and it carried 3,459 kilograms of cargo. That's 7,629 pounds for those of you in the United States, and it included food and supplies for the crew, as well as hardware for both the EVA suits and both segments of the station, hardware for the U.S. and the Russian segment. So congratulations to United Launch Alliance for this successful launch, and to Orbital Sciences, or rather Orbital ATK, for another successful mission of the Cygnus freighter, which actually docked to the International Space Station earlier this morning, but we didn't quite have time to collect footage of that. But just congratulations all around to everyone who made this mission possible.
Also of note, for those of you who've been watching launches like I have from NASA for, I don't know, forever and a day, that was George Diller's last launch. So he's been one of the main announcers for ever, it feels like. So it was a really fitting, really touching between the SS John Glenn and the George Diller announcement. I thought that was just a beautiful, beautiful way to end all of those things together. Any case, we have more launches. Tell me more.
Yes, so next up we had a Soyuz launch. This was a crewed launch of the Soyuz MS-04 spacecraft, which had 2 space travelers on board. Let's check out the footage. This Soyuz FG launched on Thursday, April 20th at 7:13 Coordinated Universal Time from the Baikonur Cosmodrome. And this vehicle carried cosmonauts Fyodor Yurchikhin and astronaut Jack Fisher, only 2 crew members aboard, so that the 3rd seat can be used for Peggy Whitson, who recently had a mission extension when they returned home in September. Now, this mission was the first of the upgraded Soyuz spacecraft, the MS spacecraft, that had a short rendezvous, which took only 6 hours from the time it launched to reach reach the International Space Station. And it did reach the International Space Station, docking with it, and they had a hatch opening shortly thereafter. And very cool. Something I did want to kind of note with the footage of the hatch opening, which you'll see in just a moment here, is it seems like Peggy Whitson and the other American astronaut kind of are sharing some sort of secret that they don't want to tell their crew members about. But in any case, this launch was successful, and the Cygnus freighter was waiting until they were able to dock successfully before doing their final rendezvous and approach and berthing, which they had today. So congratulations to everyone at NASA, Roscosmos, and all the international partners who made this mission possible.
Awesome.
So great.
Yeah.
It's always so awesome just to see like random bodies at random angles sort of floating at one another.
You're upside down. No, you're upside down.
Exactly. Oh, that's so good. And you know, so I love that vehicle. There's something really special and interesting about that vehicle to me. I like the sort of square fire at the end. I think is really cool. As I'm learning more and more about each one of the vehicles and being able to tell them apart. And then we also had a Long March 7 launch. Is that correct? This is so
That's
great.
right.
Like, what an amazing week for launches. We had like one of each almost.
Mm-hmm.
Yeah, and this Long March 7 was on the same day as the Soyuz launch, just a couple hours later. And the thing I like about the Long March 7 is it uses rocket propellant 1 and liquid oxygen, so it doesn't have those toxic propellants. But in any case, let's watch the footage of that launch.
Okay.
程序转弯。
Now, as I said, this launch also occurred on April 20th, and it occurred at 11:40 Coordinating Universal Time from the Wenchang Space Center on Hainan Island. Now, the payload for this was Tianzhou-1, China's first cargo vessel, which will dock with the Tiangong-2 space module and test the refueling capabilities, which is essential for them to start their, Mir-class space station that they have planned for the future. And everything was successful with this launch. They were able to get into orbit successfully, and there wasn't a whole lot of information about how much time it's going to take them to rendezvous the Tianzhou-1 spacecraft with the Tiangong-2. But in any case, so far the mission is going well, and I really appreciate when they have these high-profile missions that we were able to see high-definition footage of this, and just seeing the payload deployment there is really cool. And something else I find really interesting is the Tianzhou-1, the cargo spacecraft, actually is similar in design to the Tiangong-2. So when they're docked later on, it's almost going to look like there's two Tiangong modules docked together, but one of them is actually the cargo spacecraft, and it'll be interesting to see if we can tell the difference.
That's cool.
It will be. That's really cool. Jason519 in the chat room says, launches, collect them all. That's kind of exactly how it feels right now.
Can I just note as well that
Yeah.
all three of the launches that occurred this week were to a space station of some kind.
Oh, yeah, good call.
So, yeah.
That's true, yeah.
How awesome is that?
Yeah, that's really cool.
That's sweet.
Nice theme there.
It is
Yeah.
kind of funny how we live in a time where we're like, yeah, sure, it's fine. You know what I mean? Like,
Yeah.
it's
It's
become-
just another week.
right. That's
a typical
that's
week.
what we do now. That's what happens. Oh my goodness. All right, Jared, we gotta talk some money things.
Yes, you got some money?
No, do you?
No, I don't either.
Okay.
And of course, we want to talk a little bit about one of my favorite upcoming missions, which is the WFIRST mission, which stands for Wide Field Infrared Survey Telescope, which I will not be repeating that. I will just be saying WFIRST.
Yeah.
Because it's a little bit easier. But the first budget reports are out for it, and we have a good estimate of how much it's going to cost initially. And NASA's saying it's going to be about $3.2 billion in order for it to fly. So it's going to be a little expensive. But development for WFIRST began a year ahead of schedule in February of 2016, and Congress approved extra funds last year for that. Now, it was originally designed with a primary mirror half the size of Hubble, but this changed when the National Reconnaissance Office actually donated 2 full optical assemblies from canceled spy satellites back in 2011. And this is an image from, I found out, 1979 of Hubble's mirror being ground. So the same techniques that were used to develop Hubble's mirror were used for of these National Reconnaissance Office satellites as well.
Does that include
So-
the guy with the beard that probably should be covered right next to the mirror being ground?
I mean, you see how fat that tie is?
That
It's
tie-
definitely the 70s.
And that's
so,
FAT, right? Not PHAT?
Yes.
All right, just checking. I
Yeah.
want to make sure.
So,
That's
as you can see, good quality control back
That
in
is
1979. Now, this has increased the size because when you double the size of your mirror, you also end up increasing the size of your spacecraft
Sure.
that you're sending up as well. So that means that they're going to need a larger launch vehicle, and NASA is favoring either the Delta IV Heavy or Falcon Heavy for a launch in September of 2025. Now, we're going to be launching WFIRST to the Earth-Sun L2 point, Lagrange point 2, where the balance between the Earth's gravity and the Sun gravity means you could drop an object there and not have to do too much station keeping, which is very, very nice. Now, what's cool about WFIRST is that it's going to hunt for evidence of dark energy, and it's going to characterize exoplanets as well. Look at their atmospheres, potentially light reflecting off of the surfaces as well. But the cool thing to me about WFIRST is this image that we have right here. This is an image from a survey that Hubble did of the Andromeda galaxy. And it took images where you can literally resolve individual stars in the galaxy. It was an incredible study that was done. So you notice up in the top left corner there is a little box that says Hubble.
Yeah.
That's how big Hubble's field of view is. So in terms of what you can see here, it's not very big.
Right.
But the actual image here is how big WFIRST's field of view will be.
Oh.
It's going to look at a field of view 100 times larger than that of Hubble and the James Webb Space Telescope. So, and that was because of those National Reconnaissance Office optical assemblies being donated to NASA.
Right.
So that's some pretty amazing technology that they've been able to, basically were gifted to NASA. Wow. And that's pretty sweet. So thanks, NRO. Appreciate it. If you got any other stuff lying around, send it to the Astrophysics Division. We'll be happy to use it. So.
That stuff hasn't been declassified yet.
Yeah, not yet.
Be careful what you ask for, man.
I was trying to find images of the optical assembly last night, but there's nothing there because it's probably classified still. So.
You're on a watch list now.
Yeah, now I'm on the list. So.
Hope you were using your VPN.
Great.
for science.
I'm running Tor. What?
I mean, you're on a list for science.
Yeah.
So it's okay.
It's okay. We can do it.
Right. Oh my goodness. Okay, so Mike, you got some updates? And help me. If you do what you did last week, I will cut you off.
Don't be intimidated by what's in the rundown.
The rundown, you take up like a whole page.
Jeez, Mike.
All right.
What is this, War and Peace?
Where you want to start?
Well, the whole thing that I wanted to talk about is that there's been a quarterly update for the Commercial Crew Program, and Kathy Luters, who is the Commercial Crew Program Manager, gave this update and talked about the progress that Boeing and SpaceX have made over the first quarter of this year. Sure. So real quickly, let's just jump right into it. First off with the Starliner, since the last review, Boeing has completed the critical design reviews for their spacesuits, as well as the heat shield for Starliner. And then the crew access tower is nearing completion, and they had a recent test of the zip line that astronauts might use in an emergency for that. And Boeing has also completed wind tunnel testing of the launch vehicle adapter skirt. And they've conducted international docking adapter and NASA docking system testing at the Johnson Space Center. They successfully drop tested the parachutes and tested their deployment sequence of the parachutes in New Mexico. And they did acceptance testing for the RL-10 engines, which will be used both for the service module and for the launch abort system. Now, they've also been able to power on the test article, which is testing avionics for the first time as well. And Kathy Luters praised Boeing for being ahead of their development schedule for software, which has supposedly progressed so far without any problems. Now, meanwhile, SpaceX has been completing their life support systems for the Dragon V2, which includes their spacesuit designs, and they're proceeding with parachute testing. Not sure about if they're going to be doing any more drop tests, though, as well as structural testing on that test article. And they're in the middle of constructing 4 Dragons that are going to be used for the Commercial Crew Program, and there's also a chance that the in-flight abort test might not happen, as it is an optional milestone and isn't required. That's a point that Kathy Lueders kept stressing. But in any case, moving along, their crew access arm for the Launch Complex 39A has passed critical design reviews for the crew access arm and the White Room where they'll be doing all the preparations, although they still need to do the construction for that. However, with all the launches that have taken place at 39A so far, they've been able to get a lot of data about the launch pad and what sort of changes they need to make before they start operational crew missions. Now, as of right now, even though the schedules are really tight, SpaceX is still on course for their uncrewed demo mission this November, and then Boeing is going to do their uncrewed demo mission in June. And hopefully the official crew missions that will have astronauts on board and those announcements for the crew assignments might be coming this summer. So NASA is in the planning stages of getting ready for operational missions for this, and I find that really exciting. So I'm glad to hear that both companies are pushing right ahead.
That's awesome. Okay.
Sweet.
Thank you. Because like I said, I looked
Sorry.
at that and was like, we're going to be in news for
Well
the
done,
next
Mike.
hour. Goodness. Yes, really good summary. I appreciate that. That was awesome.
Fantastic.
All right, Mr. Jared,
Yeah.
you have more pretty pictures for us.
I do have more pretty pictures for us. Yes, I do.
Awesome.
And it's not going to include a guy from 1979 in it
Gah.
either. But this is an image of light from very long time ago, which this is an image of a star's accretion disk. Now, in order to explain what that is, I will tell you really quickly about what's called the nebular hypothesis, which basically says that stars and planets form out of giant clouds of dust and gas. So pretty simple.
Sure.
Now, that's always been a hypothesis, and we've been able to model it, like you could see in the bottom right down there. That's an actual computer model of what an accretion disk may look like. Using the Atacama Large Millimeter Array, known as ALMA, scientists looked at a protostar called HH212, which is only 1,300 light years away from us here on the Earth, and they've dated its age to be around 400,000 years old. So it's like it's like a 2-day-old infant in terms of
that's really
of
young.
stars. Yeah, that's very, very young.
Good way of putting it.
Now, what's so cool about it, ALMA's resolution allowed for the actual protoplanetary disk to be seen directly, and that is it in the top right corner right there. That is what the disk looks like compared to the model down below. Looks exactly the same. So guess what? The models are right. The hypothesis is correct. What do you know? Really cool result that ALMA was able to get out of that. So you're literally looking at a star in a solar system being born right now. And that is just, man, just incredible to see the baby pictures of a star like that. This is so cool.
That is a good. Is it a girl or a boy? Can we tell?
Not yet.
Not yet.
So
Okay.
you don't want to give it that kind of responsibility yet.
I'm just
It was
curious.
just born.
You're right.
You just blew my mind. I had no idea stars had genders.
Goodness.
Oh no.
Like I keep telling Kitty, I'm opting for Velociraptor. Really hoping that's what we get this time. She's not
Life
super
finds a
happy
way.
about that though. Oh my goodness. Okay. All right. So Mike, you get another update for us about other launches, but this one is just an ongoing situation over in French Guiana. Tell me more. What's going on over there?
Yeah, so I know I talked about this last week, but it seems like some really good news because French ministers and the leaders of the protests have signed an accord to end the blockade in French Guiana so that launches can continue.
Awesome.
Now, what they've done is they're going to pay 1.1 billion euros right now as a stimulus package, and then they're also going to pay 2.5 billion euros over time that'll pay for infrastructure to get a lot of the different cities and towns that do not have electricity or even running water all of those basic services. So that's what this whole protest was about, and it seems like they're going to do that, and all the different organizers are happy so far. There's still a few protesters that are a little upset, but in any case, with the launches being able to continue, Arianespace officials have said that they could resume activities there within 8 days after normal operations resume. They didn't say when that would be, hopefully Monday, but in any case, the next launch could happen in early May. Now, Arianespace has 3 missions that have been delayed since the protests that'll fill a gap that they expected to have this summer. So there's going to be 2 Ariane 5 missions and a Soyuz mission that will launch in May and June as they get their schedule back on track for the rest of the year. So very exciting news, and I hope that there's no more protests or civil unrests and launches can continue from there.
Yeah, no kidding. Yeah, it's such a gorgeous launch site. I think, it's not on the water, but it's like right. I don't know. I like all of the things, I
very pretty.
suppose. Like, Ben will yell at me for calling everything awesome, so I'll stop. But it is. Jared,
No, it's
go ahead.
Go ahead.
No, go ahead. You were saying?
Oh, I was just going to say it's a nice contrast from like Cape Canaveral, which is very swampy.
Yeah.
Still beautiful, but very swampy. But then the Kourou, has a lot more palm trees and just looks more jungly. And, that whole line, Rumble in the Jungle, is very fitting.
Yeah, exactly. There. Good. I got my awesome bin. Okay, Jared, you've got one more story for us
Yes.
before we go into break and on to all the other awesome things we've got going on this episode.
Yeah.
Tell me more about other pretty pictures.
Yes, more pretty pictures. Everybody likes pretty pictures. I like pretty pictures because it's data, and that's really important stuff.
Yes.
So there's this very cool telescope. There's somebody that was actually, I saw in the chat room last week, and I was like, whoa, what's this? So there's this cool telescope called the Event Horizon Telescope, which is a system that has been developed to try to actually image a black hole directly for the first time. Now, it's been in operation since 2006, and they have announced that they are going to be releasing the first image of a black hole sometime next year. Now, the Event Horizon Telescope was looking at a place called Sagittarius A star, which is that's actually what's called Sagittarius A star.
Love it.
It's not an asterisk, it's a star apparently. And that is at the center of our galaxy. That is where we think the supermassive black hole that is several million times the mass of our own sun is sitting at. Now, the goal of the project was to provide those first direct images of the black hole, and the images that it just recently took were taken between April 5th and 11th. And the instruments had to wait for material to be falling into the black hole for sufficient light to be generated, because they're trying to look at the event horizon's shadow coming off of that.
Sure.
So about 500 terabytes of data was collected by these telescopes. Now, I said telescopes because the Event Horizon Telescope is not one radio telescope. So we're not looking in the visual wavelengths, we're looking in the radio wavelengths. But it's a collection of them. And if you want to read them all, you can pause and take a look at it on your own.
Yeah, that's everywhere. That's crazy.
Yeah, they use a technique called very long baseline interferometry. And what that does is that allows you to combine all of these radio signals together, and it basically generates a radio telescope that is about the size of the Earth. So if you can imagine that kind of, that size.
Well, going back a story you were talking about, well, two stories, I suppose. The bigger the mirror, the more things you can see, right?
Yes.
So that's the same concept here, yes?
Exactly, yeah. The bigger the mirror, the better your light collection, the potentially better your resolution can be. So that's why they did that here. So they've now taken all that data and they are assembling it using supercomputers at MIT's Haystack Observatory, and this is going to require about a year's worth of round-the-clock work. So what's so cool about this is that we should get an image that actually will look a little something like this. Whoa. So this is sort of a computer model of what the Event Horizon Telescope may actually be able to produce in terms of its image. So you see the material falling in, super bright, and then the actual event horizon as that sphere right there. So this is going to allow for comparisons to models that we make here on Earth. And this is going to tell us whether things like general relativity are correct or not, because this will be one of the most precise tests of general relativity yet, since relativity pretty much governs the physics of black holes. So this is very exciting, and I can't wait to see the images from next year. So stay tuned. We'll cover it when it happens again. Wow. So yeah, very, very cool stuff.
I needed, like...
You okay?
Yeah, yes.
Need some air?
That is really...
No, I need some air too after seeing that.
Really gorgeous.
Yeah.
Oh my goodness. Okay, that is a super fitting end to news at the moment. All right, so what we're going to do is we're going to take a break, and then when we come back, Ben is going to be on the observation deck with a lovely interview. We're talking about Cassini.
Yeah.
Stay with us. We'll be right back.
Close your eyes and picture your favorite city. What do you see? A graceful skyline of towering buildings. Cars and trains bustling everywhere. Crowds of people working, shopping, and visiting, maybe for the first time. Tomorrow sees cities a little differently. We see buildings, but also a thriving ecosystem. We hear the cars, the trains, and envision a better way. We see cities as a place to call home, and as a place worth the journey. Cities with a past and a present, but especially a bright future. Come with us and explore the cities of tomorrow.
And welcome back to Tomorrow. Now, before we get started with our interview, I did want to give a huge thank you to all of the patrons of Tomorrow who've helped to make this specific segment of this episode happen. These are people who've contributed $10 or more to this specific episode. There are Escape Velocity members. We've also got our Orbital subscribers. These are people who've contributed $5 or more to this specific episode. A huge thank you to everyone for making all of these shows possible. To find out how you can help crowdfund the shows of Tomorrow, head on over to patreon.com/TMRO. All right, we've got a special in-studio guest, Lisa Taji from JPL, correct?
That's correct.
And you're working on the Cassini mission, and you're a subsystem engineer on the spacecraft itself, and you also work, do you work in the control room, like sending commands to Cassini at all, or you just...
I don't send them specifically, but depending on what we're doing, I do in fact give a go at a time at times, which is kind of cool. You know, I mean, you get the headset on and you're ready to go. It's great.
Have you ever given a no-go, or have you always been able to be like, no, we're go?
In all cases, I have been able to say go at this point, especially for this mission. It's been rather uneventful in many ways. We've had so few errors in in events like that it's just. It's been a real workhorse and an amazing spacecraft.
So let's back up and let's talk about what the Cassini mission itself is.
Well, if you backtrack just a smidge, those of you that were around and remember the Voyager missions, they started out launching from, that's a good picture, I love that one. They flew past Jupiter, Saturn, Uranus and Neptune, at least Voyager 2 did.
Sure.
And when Voyager 2 went past Saturn, there was a lot of questions that got asked. It's like it answered a few things, but we had a lot of new questions. And the same thing happened with Jupiter. So shortly after they went past Jupiter, they started thinking, well, let's send something to Jupiter, and therefore we get the Galileo mission, which wound up spending a lot of time at Jupiter, and then we had all of these things to do, and we thought, well, just send something to Saturn. Now the problem is, we originally had, we were going to build a whole fleet of these.
Cool. Yeah. All right.
Beautiful things.
Yeah. Like nice model.
Yes.
Yeah.
Yeah. We were going to build a whole fleet of them, and then we were down to 2 for budgetary reasons. And then again, there was another cut, and we lost the other spacecraft. So we have just Cassini that survived all of the budget cuts.
Would there have been something more we would have been able to do with the fleet? Were they supposed to like work in tandem with each other, or was it just to gather more data faster?
It was to have a basic platform where you change instruments. So when I joined the mission in 1991, there were 2 spacecraft we were going to fly. It was this and the Craft mission, Comet Rendezvous Asteroid Flyby. So it was going to have a different suite of instruments on board, and then go out and study comets and asteroids. It was similar to the Mariner missions initially, where there was a whole fleet of Mariners, and this was going to be Mariner Mark II. So this is the only one that remains from the original Mariner Mark II. Yeah.
What are some of your favorite parts of the Cassini spacecraft? Like, I mean, it's been up there for a while. I mean, if you could pick out some of your favorite elements.
Well, it's interesting because we've got 12 instruments on board. And then there was another 8 that was on the Huygens probe, which is the shield piece on the front. The magnetometer, it sticks out here. And the fun bit with the magnetometer is that it actually collapsed for launch, because you can't put this in a nose cone on a rocket, right? So it was all collapsed down into the box down the end over there. And then after we got out of the inner solar system, we trundled it out, and it popped a little cap off, and then the magnetometer rolled out. And we've actually got 3 instruments. There's one here, one there, and then one closer to the spacecraft. And the reason I like that is because it's one of those things where the spacecraft, everything that has electronics generates magnetic fields. You don't want to sense the spacecraft, so where do you have to put the magnetometer? Way out the end of the boom. Sure. So that's why they're sticking out here. And I don't have the RPWS antennas on those. Those are actually quite extraordinary in that they are round. They were wrapped metal with coating on the inside, and they rolled up into a little tiny box. It was about get rid of this for a second. There's a little box about yay big that sits on the back of the spacecraft, and all of them rolled in. It was like a big roll, like a measuring tape. And under similar circumstances where you send your measuring tape out and it unrolls and pops up and is stiff and has rigidity. And so I actually got to send the commands at one point during testing to extend those while we were in the chamber. That was one of my favorite memories of the mission, actually.
So you actually got to see it happen then, like you're sending the command to the spacecraft because it's here on Earth.
Yeah.
You actually watched your command get executed.
And it's funny because I initially wrote flight software for the mission from 91 through about 96, I think, is when I transitioned over to the integration and test and helped do the testing for launch. But the software that I was writing at that point was all in an internal box up in the electronics ring. Oop, don't take that off. Electronics ring here, and there's no monitor on it. There's no, you have nothing in the way of feedback except something that turns from a 0 to a 1. Now, mind you, in the middle of the night when you're sitting in the lab and you've been spending days writing software and you sit down and go, run this, run it, let's see what happens. You sit there and you wait. And the 0 goes to a 1, and you have no idea how happy you are. So it works. But when you're actually sitting there and watching something physically happen, it's not in the virtual world anymore.
Sure.
That was one of the things I really, really liked, was watching the RPWS antennas go out and say, okay, send this one. I'd send the command, and then I'd lean out and I'd watch the antenna extend. I'm like, that is so cool.
Do you happen to know what RPWS stands for?
Yeah, Radio Plasma Wave Subsystem. And what they're looking for with that instrument is the radio plasma that is generated, the particles that are generated when the solar wind hits the magnetic field around Saturn.
We have two quick questions from the chat room. The first one comes from Toby asking, what scale is this model that we're looking at right here?
1/25.
All right.
Yeah. The actual spacecraft is, and I apologize because I do, I remember numbers for things on the spacecraft. Some of them are in English units and some of them are in metric, so I apologize if I swap between the two. The spacecraft
just to mess with everyone's brain.
Yeah. The spacecraft is actually a little over 2 stories tall, so about 22 feet, and that would be from the base of the engines there up to the top of the feed horn. And the dish itself is 11 meters, and this is 11 meters out. So, excuse me, this is 11 meters out. It weighed about 6 tons at launch. Most of that was fuel. And for those of you that don't realize, we had to slow down. We had to burn the engines for 90, I think it was 94 minutes. It was a little over 90 minutes to slow down once we got to Saturn. So we had this huge fuel tank, and the fuel tank actually starts at the top of the ring here and goes all the way down here. So it's the entire center section of the spacecraft, and the structure itself only weighed about between 2 and 4 tons. 2 tons, weighed about 2 tons. And so the rest of it, up to 6 tons, was all fuel sitting in the internal
What was your
section.
approximate velocity when you were approaching Saturn before you had to do your braking burn?
You know that I don't off the top of my head know. I will look it up for you if you guys want to post it online after the fact. I'll have to go look it up. But I do know that we had to go, because the spacecraft is so large, I mean, this is something that you deal with when you're developing a spacecraft. You have a lot of trade-offs that you have to make. So you say, all right, I want to send this instrumentation in there. We've got 12 instruments on board. They weigh this much. The superstructure weighs this much. We have to have batteries. We have to have an antenna for the radar. We have to have an antenna for communications. So you say, okay, this is how much that weighs. And then you think, okay, I have to get it. How much fuel do I need if I have to go directly to Saturn? And you go, we can't carry that much fuel.
Right.
It just is impossible to do so. So what we wound up doing is what I like to say to everybody is we went the wrong way first. So Saturn is out from the sun, from the Earth. We actually went towards the sun. So when you're launching a spacecraft, if you launch forward in the motion in the direction of the Earth, right, you pick up speed. If you go out the other direction, you actually slow down with respect to the Earth, and if you're slowing down, you can't maintain that orbit, you start to fall in. So we actually went past Venus once, and Venus and Earth a second time, then Jupiter, to get our gravity assist to get out there. So we were really screaming by the time we got out there. We were moving very, very fast.
I bet.
Which is why we had the hour-and-a-half burn.
Yeah, Jupiter's gravity well, not small.
Exactly. Yeah. The best bit about doing the Jupiter gravity assist was that we actually got to do some joint science with the Galileo spacecraft that was still in orbit at the time, which was kind of cool. So we were looking at two different areas of the magnetic field and that sort of thing when we went by, and then different types of photographs and all that, and the cooperation on the data, and we worked out a thing to try to actually do that. So we said, okay, we know you're here, and then we did a joint data set.
Did we get anything awesome out of that data?
Anything off the top of my head, I don't know. Again, I could go look that up.
We'll have lots of show notes for this
Oh,
one.
yeah.
Lots of show notes.
Oh, yeah.
All right, so this is actually right. This isn't coming up. This is actually at the end of its life at this point. So
Yeah.
you've been at Saturn for a while now.
Yeah, we launched in 1997. One of the most beautiful launches I've ever seen. Went up on a Titan 4B, which, it's one of the most beautiful night launches I've ever seen.
Look how large that fairing is up top. I mean, that's you. That's the Cassini spacecraft.
Yeah,
up there.
we're up on the top, and it didn't. I'm trying to remember if we filled up the whole thing or not. I didn't actually get to see it when it was on the pad. I did get to see it here. That's actually my favorite picture of the spacecraft. This is during what we call shake and bake.
Oh yeah. Sure.
Assembly.
I mean, it's self-explanatory.
Launch,
For those who don't
test,
know, I mean, you literally have to
yeah.
shake it and then basically run it through a series of launch-like conditions to make sure it will survive.
Yeah, so you put it on a table and you shake it like so that you get the vibration that you're going to get during launch from the rocket, and then you put it in a room and you bombard it with sound, because it turns out you actually get a lot of the vibration on the spacecraft is not actually from the rocket shaking, it's from the sound that the engines make during launch. And then the other thing we do is we take it across and we put it in the chamber, which is what that picture is. So you see this huge chamber, and we just barely fit. That's the 150-foot space simulator at the Jet Propulsion Laboratory. And it's like a giant submarine thing. It's got this big door on the front. And they slide the thing in there and tack it down and make all the cables come out, seal the door up, and then evacuate the chamber, backfill it with nitrogen, and make it cold, and make it nothing, so that it's in as much space-like conditions as we can get. And then we've got this huge array of arc lamps that sit underneath the chamber that generate sunlight.
Yep.
And we
Go the
bounce
other
it
way,
up.
make it really freaking hot.
Yeah, we bounce it up on top, which is why when you're looking in that image, it looks like it's lit from the top. It's because we had set it up that way. The idea is that you want to know how the spacecraft is going to perform in a space environment, and you do the best you can. You can't always get it perfect, but you get as best you can, and you test and you test and you test. And a lot of the testing I remember doing at that point in the mission was thermal. So we'd spend time, okay, we turn this instrument on, we turn this off, we turn that on, we turn this off, and we were looking at the thermal profiles for the entire mission, and we did that for a number of days, actually just making sure that it was correct. And we had 3 shifts going, and we're testing for several weeks on end before we took it back down to the assembly facility and finished up testing.
Successfully made it to Saturn.
Successfully made it to Saturn in 2004.
That's a ways, right? You launched in the 90s? What was it,
Yeah.
97?
Yeah, 7 years.
Yeah.
It was a long time. And we weren't going to do any science en route, but we actually wound up doing a few things. We tested a few things when we went past Venus, and we tested a few things, as we said, we went past Jupiter.
In general, the spacecraft is asleep at that point to conserve energy.
For the most part,
yeah,
because you don't want to waste your batteries. You
Sure.
know, I mean, in our case, we've got the radiothermal isotopic generators, and
that just rolled right off the tongue. You have said that more than once.
Yes, I've been doing that for a good 20 years now, at least. But yeah, those are the main battery power for the spacecraft, and they do decay on their own. But the less you draw on them, the better off you are. And also, it also saves some money because you don't have people that are working to write sequences to turn stuff on. So yeah, it's you can have a little downtime and work on stuff, other things that you need for when you actually get to encounter.
Is that generally what you do during the day? I mean, 7
A
years
lot
is
of
a
them.
really long downtime.
Yes.
I mean,
Look at New Horizons.
Sure, absolutely, right? So in general, are you, during that downtime for any of these planetary spacecraft, right? 'Cause
Yeah, a
good
lot
chunk
of them you don't. Yeah, unless you're doing things like picking up fields, particles, or those sorts of experiments while you're flying. Yeah, you try to conserve the instrument and don't use it or damage it while you're en route. Now, usually, like I say, on occasion you sit there going, we really have to test and see how this is working. Yeah, and a lot of times you'll have things where you do checkouts just to make sure everything's still working. So you turn everything on and you go, yeah, everything's functioning, and then you turn it off. And so all of those sorts of things go on.
Any gotchas while you were on the way? Like you turn it on, you're like, that's not supposed to do that.
We did have one, had to do with the Huygens probe. The Huygens probe was built by the European Space Agency. There's 17 countries that were involved in building this spacecraft. It was a real international effort, and one of the first times that we'd had that kind of cooperation between countries in that fashion, and it's been quite well, and everybody uses it now. But we were one of the first folks to actually take advantage of that. But the Huygens probe was built by ESA, and the Huygens mission was supposed to launch the probe. It was supposed to land on Titan, and we were supposed to pick up the data with the spacecraft as it went by. During a test, somebody found out that the design of the relay antenna that was supposed to pick up the signal from the probe was not capable of picking up the frequency range that we needed. And so what they realized was part of that was due to Doppler.
Okay,
because the spacecraft,
the wave is stretched or compressed.
Right, that the spacecraft would have been moving too fast past it at some point, and it would have been out of range of the antenna. So what we wound up doing was actually holding on to the probe for another 3 orbits before we actually dropped it off, so that when we went past Titan for the relay, we were at a higher altitude and therefore less Doppler shift between us and the probe in order to manage to get that to happen. That picture right there, one of my favorites. It's the first time that was ever done. We had one spacecraft take a picture of another. This happened right after
It's hard to tell, though.
Yes.
I mean, that's a lot of black and white.
Well, yes, and it was quite a ways out. But we set it up so that right after we released the probe, and that was on like Christmas Eve, I think on 2004, yeah. We released the probe, and then one of the things we did was turn around immediately and try to grab this picture. But of course, that immediately, if you've ever tried to turn anything around in space, doesn't happen immediately. It takes some time to do it. You do it very slowly so that you can control your rolls. So there was a little time, and it had to get out of the way. We wanted to make sure we didn't hit anything on the spacecraft with it. We had to wait until it was out of range of the spacecraft. But we did actually get that. It's the first time that was ever done.
Rebel Ace Frislin in the chat room asks, what would happen if the Huygens module didn't detach?
Oh, that would have been interesting. We would have had to hold on to it if we couldn't actually get the bolts to fire. Is what you're referring to. We would have had to have carried that on, and the extra weight would have cost us fuel because it did for those extra 3 orbits. Our attitude control folks. I worked on the command system. The attitude control folks are the ones that they determine how much fuel we use, and they try to economize it as much as possible. And they did an absolutely heroic job late in the mission, where we figured out how to do certain activities where we could actually save some of the fuel, which is how we got to 2017, because nobody anticipated when we launched that we were ever going to make it to 2017. The longest we expected was 2012, I think, if we had gotten an extended mission. And so that was, the original mission was 2004 to 2008, and then if we got like an extension for a couple of years, it would be at 2012. And so when we finally got there, we said, hey, we got fuel. What else can we do? And there was thought at one time of actually leaving Saturn. Apparently there was a possibility of doing that. And they had talked about some options, but at that point we already knew there was something weird going on at Enceladus, and we were already intrigued by some of the stuff we had learned about Titan. And we thought, no, let's stay. But then, as the project head likes to say, you know, you can't go home, but you can't stay here. So that sort of set up this end of mission. We have to crash the spacecraft because we don't want to hit any of these objects that are in the Saturnian system.
So before we get to the grand finale, let's
Sure.
talk a little bit about what did you find? You've made it to Saturn. What did you find once you were there?
Oh, I got some cool stuff here. Let me look at my list here because, you know, the brain does fail when you're trying to think of
This
things.
is an incredible image they have up on the screen right now.
That
This
is actually
just
one of my
beautiful.
favorites. So you can leave that up there for a second. That is the, we call it the backlit Saturn photo. That one we took when Cassini was behind Saturn with respect to the sun, so the sun's on the backside. Now when you're looking at the image, the rings on the lower portion of the screen are farther away from you.
Okay, yep. Mm-hmm.
So when you look at it, if you see there's a little bright spot off to the left in this bright effusive sort of ring that's out there, that's the E ring. And that little dot out there is actually Enceladus.
That's the one. So there are two little dots, it looks like, on the screen.
Yeah,
right?
the other
so there's
one
one at
there
the
is
bottom,
something
and then there's
different,
yep.
But the one over there is, and I'd have to look up which was which, but the one that's over in the corner, that's actually Enceladus. And it is the one that is creating all the material that is in that E ring. So that's how all that material got there, and it's something we found once we got there. So that was something that was quite extraordinary. We did not anticipate what we were going to find. Enceladus really kind of blew our minds. Earth is actually in the picture as well. It's a tiny dot just under the main section of the rings on the right side.
I will believe you. I can't see.
Yeah.
Oh wait, no, I see
Yeah.
it. Yeah, absolutely. It's harder for us to see
Yeah.
in studio. I'm sure the people watching
Yeah.
in 4K are like, it's right there.
That's right,
Yeah,
yeah.
but yeah, kind of on the right side. Yeah. Mhm.
So this picture was actually taken on a day that we did an event called Wave at Saturn, which was kind of one of those things I thought, hey, why don't we do this? We're going to take a picture of the Earth. Let's have some fun. So we did some math. There's 141 images that were used to take this. We're a little too close to Saturn to get it all in one frame, have been since shortly before launch. But in order to do this, we had to take 141 pictures kind of in a raster, and you go down the bottom. And we knew when we were going to take the one that was pointing at Earth, because we know what the pointing is for each of those images. And so we said, okay, fine, we need to take the picture at this time. So if we back up one-way light time all the way to the Earth, and then we know, okay, everybody needs to smile or wave now so that the light from that will reach the camera at the right time. And it was such a great event. We had an absolute blast.
Oh, that's incredible.
With that, we had people.
Did you actually go outside and wave at the
Yes.
camera? That's amazing.
Everybody, we had a whole group of folks that were at the lab. We were outside and did that, and there was people who sent in photos from all over the world.
Oh, that's incredible.
They had little star parties, and they all did Wave at Saturn parties. It was absolutely just an absolute blast. But this is one of our favorite pictures. The one that freaks everybody out, though, is when they're, if you go back to it a sec. Yeah, if you see the rings there at the top, you think, why can't I see those?
Why can't I?
Yeah, because it's a little odd. Why can you see, why is there a glow on Saturn on the backside?
Oh, that's actually a good point. Yeah.
Well, it turns out what's actually happening is everything that you see that's dark in that image is where the rings are thicker and the sunlight cannot get through. Every place it's lighter, the rings are thinner and the light can get through. What's happening at the top there is that the ring plane is actually getting some sunlight, and it's bouncing the sunlight from the thicker portions onto Saturn and then back.
Oh, that's really cool.
So you wind up with this really interesting sort of light bending image there. And it's one of everybody's favorite images of the entire mission.
This is a stunning image. This is an absolutely stunning image.
Yeah, it's absolutely beautiful. Mm-hmm. Yeah. Okay. What's the next one you showed there? Or we can look at that because that was kind of cool. Oh, that's my favorite. That is my favorite picture. of Saturn right there. This is when we, shortly after we got to Saturn, so it's early on in the mission. And you can see that the sunlight's on the southern portion of Saturn. And when we got there, it was southern summer. So the rings were up with respect to the sun, and so it was highlighting the bottom portion of the planet. And that little moon there, I believe that one's Dione, that's hanging out there in the middle. And you can see just how thin the rings really are. They're only like 10 kilometers maybe thick. I mean, they're not really that thick compared to the entire size of Saturn, which is 764 Earths, I think you can fit inside of Saturn. So they're very, very thin, but then they're very expansive. They're hundreds of kilometers in width. And if you include the E-ring out at the edge, it gets even bigger.
Sure.
The reason it's blue at the top is you got a little bit of diffuse light up there, and you get a little change in the chemistry, I think, up at the top as to what color stuff is, because it's warmer or not as warm, because it's in shadow. So we just roll through them.
Was that a multi-image as well, where they just take a
that
bunch
one
of
had
pictures?
to.
Yep.
Yeah, and there's certain ones that you can tell that they had to. This one, I think they got. This was one camera image. This was the Great Storm. All of a sudden, we get to. You can tell this is just past equinox, because we now have light on the top side and the shadows are on the southern hemisphere.
Sure.
So now we're getting a little more heat on the northern hemisphere of Saturn, and now you can see it's got this storm that came up out of nowhere, and we started watching it, and this is at the end of the storm. It actually wrapped all the way around Saturn and it met its tail, and then it sort of burned out. So you can see the remnants of the original down below with the sort of bluish colors, and then the white up at the top. And it was actually hotter. It was pulling up hotter material from lower in the atmosphere.
The size of that storm's got to be immense when you're looking at that, because I mean, if it's 700 some odd Earths in the size of one Saturn, I mean, that's got to be
enormous.
Yeah, I mean, just huge.
Yeah. And it was one of the really interesting science discoveries, is that we actually got to see this, because most of the time, I mean, you can tell Saturn has a lot of, especially when you look at it in infrared, you can see a lot of structure. There's a lot of stuff going on. It looks a lot like Jupiter, where you have all of these little storms and everything going on, and you can see the layering just like you do at Jupiter. But for the most part, in visible light, it looks a lot smoother. So when this sort of came up and you're looking like, wow, okay, that's exceptional. Yeah, so that's one of the things we had a lot of fun with. So we can go to the next one. This is what I think, this is one of the last ones we got where we didn't have to take multiple photos.
This feels like one of those iconic pictures that I see everywhere on the internet. You see it in museums.
Yeah.
Right? I mean, this is like that picture of Saturn.
It was a big deal because it was the last time that even in our wide-angle camera lens, we could get the entire planet in one shot with the main rings. After that, everything is in pieces.
And actually, one question from our chat room from Lance is asking, are these in true color?
This one is, yeah, but when you have to remember, when we take images, it's a digital camera, 1 megapixel. You've got more on your camera these days.
Yes, but again, you launched in '97, which means you built it before then. So 1 megapixel in the mid to early '90s was ginormous.
And but what happens when you take these, and I've worked with at least 2 missions now where they've got digital cameras, and what they do is they take multiple images, one without any filters on it, so you just get like a black and white image, because all it really does is says how bright, how much light am I getting at this pixel, and it assigns a number to it.
Sure.
And so you do that for all of the pixels on the screen, and then you go, okay, I'm going to do that again, but let's do it with a red filter. And you take all of that data and you store it away, and they said, let's do it with the blue filter, and you do it with the green filter. And so you wind up with about 4 images that are required to put this together. But yes, if you were hanging there at Saturn, that's what you would see.
Now, at least in the video world, chrominance is not as important as luminance. So the color data, like we throw most of the color data away in video. Do you do the same thing for the spacecraft, where you go, all right, let's get the luminance shot, and then let's just get a low-res chrominance of this, and
I don't know how they deal with that. I'll have to ask the ISS guys. imaging subsystem, by the way. If I fall into the alphabet, Stoop, stop me.
That's got to be confusing when one acronym means multiple things.
That kind of freaked me out. I had one where I was on Cassini for a while and I moved on to another mission, and then all of a sudden they were both using the same acronym and they meant absolutely nothing the same thing, and you're trying to deal with it and you're like, so, okay, I'll put this hat on. All right, that means this now. Okay, that's how you deal with it. This is definitely false color, but this is the hurricane that is in the very center of what is called the hexagon.
It looks like something out of a Marvel movie.
It does,
The villain has created some sort of super hurricane.
It's going to eat all of the Earth.
Yep, exactly.
As a matter of fact, it's a little smaller than an Earth because the hexagon is about 2 Earth diameters wide, and this is down in the center. But the false color is always done for the scientists to see a little more detail. So they, in this particular case, they did it. And I'm not sure. I'm not sure which instrument did the imaging for this. It was either might have been VIMS, virtual infrared. But these are. You can see the structure where it goes. It looks like you've got some depth to it, and it's been there since Voyager was there. So it's the hexagon.
And the hexagon was an area of interest.
Yes, it definitely was. And when we first got there, we couldn't actually see it because it was in the dark half.
Sure, yep.
Right, so we had to wait. This here is actually the one that's at the southern pole. And there's no hexagon down there, and it's not as refined. I mean, you don't have, look at it, it's very irregular. And you sort of look at it and you go, well, why is the northern region so much different than the southern? And scientists, they just don't know yet. It's one of those we have no idea.
We're going to have to send more spacecraft out there.
Yes, I think we are. That would be great. So get the next one. Okay, this is one of our very new images. This is coming out sometime in I think it's in the last 6 months. This is Moon Daphnis. And Daphnis is in clearing that little gap you can see in the rings there. And all of that distribution that's going on is from Daphnis pulling the material towards it as it travels.
Oh, wow.
Through the ring. So what you have is, and it looks at it and you think, well, why have I got material on both sides? Looks like it's disturbed. Well, if you have anything that is rotating, anything that's on the inner portion rotates faster than stuff on the outer portion. So what you have in the gap there is Daphnis is moving faster than the stuff below it. So it's actually moving in that direction. So it drags stuff with it as it goes.
Sure.
But then the rings out behind it are going faster, and so it's dragging past, and you wind up with the waves going the other direction.
That's kind of incredible.
It's very cool.
Is it attracting any of that and making itself larger, or is the gravity of Saturn just not allowing that to happen?
If you want to go to the brand new pictures on the moon stuff, in the pickup Pan and then Atlas. We have these new images came in because we were never able to get close enough, and this is something that's happened towards the end of mission here, where we're getting right outside the F ring. So this is Pan, and these images absolutely, they came out, and the scientists, the email trail I heard was 20 long inside of about that many minutes, because they were all looking at these images and just going, look at that. And I've got just enough geology in my background for me to look at this and my jaw hit the floor. One of the things in geology is cross-cutting. So anything that cuts something else is newer than what it cut.
Sure.
Right? So if you look at the image, you can see the stuff, the ridges that are moving from right to left. And then you can see the ones that are going top to bottom. They cut those. And then you can see that there's this little skirt of material around there, and that seems to cut off some of the, and then you're looking at the craters. The thing that surprised everybody was that the craters in the skirt are still there. They expected to be a little more effusive than that, and it's actually solid enough. But yeah, they think what it's doing is actually pulling some of that material to itself.
That's really incredible.
Yeah, so it wounds up, but it's not, and this is the difference, though. This is Atlas.
Sure.
This is the one we just got a couple of weeks ago. this image came in. And it looks, in some ways, very different because you don't see a lot of cratering or anything on the skirt in this case. It looks a little more diffuse. So they're very different. And if for those of you that watch the time-lapse photos, the thing looks like it's rolling. It's not. That's our perspective as we went past it. Yeah. So those of you that think, oh, it's rolling. Well, no, we're not even sure they're rotating.
A couple questions from the chat room. One comes from Anomaly, which is how long does it take for these images to get back to Earth? Let's do average time because that's going to shift depending upon the distance between Earth and Saturn.
Average time is somewhere between 2 hours 45 and, well, excuse me, an hour and 15 and an hour and a half one way.
And let's tie that into, we've got a few more images. Actually, let's do a few more images.
Yeah,
right?
sure.
Then I'd like to talk about the grand finale because that goes into the bandwidth conversation we had earlier, which I think is going to be really interesting.
Yeah.
So
these are called propellers, and you can see we've got little bits of material that are in the rings that are doing something similar to what Daphnis was doing. And so you wind up with the material being disturbed fore and aft. And these were something that were discovered with Cassini. I don't think Voyager had the resolution to catch these. But the other thing you can see is the ridges as you go through. It looks like record grooves. And the material is denser in some spots and not in others, and in odd ways. The radio science folks have been doing like this image here. The radio science folks have been doing what they call occultations. So they will sit on one side and they will send a signal to Earth. And then as we pass behind with the spacecraft, they can get a signal, not get a signal, get a signal, not get a signal. It gets them an indication of where we have gaps and where we have less material and where we have more material in the rings. So they do that, and they get data on the atmosphere of Saturn and how thick it is in certain spots and how it bends the radio signals and stuff. It's quite cool. So here's our...
Now the E-ring you said was from Enceladus. That's the outgassing or the out-oceaning?
Out-oceaning is probably, that's a good word.
From Enceladus. Correct, right? So that's basically water vapor?
Yeah. Yeah, there's a little bit of other stuff in there, as we have found out. If you're interested,
There you go. Yeah, right. So and that another iconic image.
Yeah, this is when this came out, somebody made a really big poster of it and hung it up in one of the hallways.
That's got to be incredible.
And it was it's a good 4 or 5 feet in length, and you look at it and you can't stop staring at it. Every time I walk by, I'm looking at it. We started to notice that something was a little odd going on with Enceladus starting in 2005. We flew past, and the magnetometer guys said, hey, we got a signature that kind of reminds us of like comets or something. And if you can find, there's a thing with the magnetic field on it. Tim, it's in there somewhere. There it is.
Look at that.
And you can see that we had a little disturbance there. And so we said, well, it's kind of indicative of something going on. And we went by later and noticed that it's very hot down there. There should be another image that's we've got the thermal one. And those are what we call the tiger stripes. And when we went past later, you'll see that you get the jets out the bottom. And we've actually flown through them now to taste them because some of our instrumentation is capable of doing that. And learned that, yes, it's mostly water, but there's also little particle sizes in there that's kind of set up for, that is Enceladus spewing into space. I love that picture.
And then getting sucked into the gravity well of Saturn and becoming the E-ring, essentially, right?
Yeah. And it's only the particles that escape from Enceladus that cause this. Some of them actually fall back on, which is why Enceladus has a less cratered look than some of the other moons, because part of the surface is being resurfaced. And you can see here, this was the stuff from a few weeks ago where they were looking at, because those little tiny particles that they found in the plume when we flew by, they're indicative of having water, like a salty, watery type ocean, hitting a hard rock, hot surface underneath. And if you go to the other one, I think that's the other graphic, this one here, this is the one that just came out when they announced that they have determined that this could support life because it's very similar to what we have at the bottom of our oceans. So we have what they think are hydrothermal vents that are down below that's heating this water up, which is why we actually have an ocean. It's liquid, and it does go all the way around the planet. We had to do a number of flybys to confirm that, but it's not just at the South Pole. It does actually go all the way around the moon. And so you have this like 5 kilometers of ice at the top, and then you have this big thick ocean about 65 kilometers, and then you've got your hot core underneath, and it's creating this bubbly hydrothermal vents with what they call smokers. And we have those in the bottom of our oceans here on Earth, and we have a lot of critters living
that seems
down
like
there.
a really great place. We want to find life in our own solar system. That
Yeah.
seems like a really. All we have to do is figure out how to drill down through 5 kilometers of ice
Well, it's
on
either-
a spacecraft.
Yeah.
Yeah.
Yeah. Well, we actually have something similar going on, we believe, at Europa, at Jupiter. And the laboratory is actually working on a mission right now called the Europa Clipper that is supposed to go to Europa and go find out. And we'll see. I mean, we know what it's doing, and we do know that it's actually outgassing in two locations for the most part. And it's at whether it's very close to Saturn, it's getting squeezed due to the gravitational forces at that point. When it gets out at the far end, it's getting stretched a little bit, and then the cracks open, and we actually get some out as well at that point.
Quick question from the chat room. Marty Scher asks, you had mentioned Cassini going through and tasting some of the plumes from Enceladus. What does tasting involve?
We actually have a couple of instruments that are capable of grabbing dust or particles and actually determining what the composition is. And one of them is our ion and neutral mass spectrometer, which is exactly what you think it is. It's a mass spectrometer in the same sort of fashion. You can, if you got something with an ion particle or whatever, depending on how far it goes into the detector, the more massive the particle is. So it tells you a little more about what it's made out of. We also have a dust analyzer that's on board, and the cosmic dust analyzer. And so its job is to suck in dust and try to figure out what it is as well. So between the two of them and some other things where we've got stuff that can look at things in different types of light, if you start to corroborate all the information from all of those instruments, then you start to get an idea of what's in it. So we know that most of what's coming out of the South Pole of Enceladus is water, but there is a small portion of it that is not. It's got some other stuff in there, and the biggest thing, of course, that came in just last week was that it's got hydrogen, which is a big precursor saying, yes, something is chemically nice down there for life. So we shall see.
That's pretty cool.
Yeah,
I've got 2 similar questions. This one, we'll start with the first one from LBCG, which is, I'm going to tweak the question slightly, which is there anything observation of Titan which surprised you? But let's broaden that and say, are there any observations of any of the moons or of Saturn that surprised you?
Aside from the plumes on Enceladus, if you want to go over to the Titan stuff, Titan. We knew some of what was going on in Titan before we left. We knew that it had a very thick atmosphere, and we knew that we couldn't see through it, and we knew that Voyager, when it flew by, it was just looking at this giant orange ball. It didn't have much structure to it. So we knew that, but we also knew based on occultations, we could do star occultations from Earth, and we could wink on and off, and we get some idea of the chemicals that are involved. So we knew that there was hydrocarbons there, liquid methane and ethane. Those were known before we left. But the theories prior to launch, I remember reading in a document, and they said there was anything from a completely liquid ocean on the surface to completely dry and everything was in the atmosphere in gaseous form of some sort, or in liquid form held in the clouds or whatever, and it was dry on the surface, to something in between. And we wound up with not only something in between, but some of the best geography you've ever seen. It looks so much like Earth in some cases. It surprised us, a lot of us. And we wound up realizing that we have a hydrologic cycle of sorts. It's just with methane and ethane. So we actually have, if you want to cycle through these are actually dunes. And the dunes are, they're basically made up of ice crystals. It is so cold that water is frozen solid. There's no liquid running on the surface of water. So it becomes rock. So now, but we're noticing things are cutting this, and we've got tributaries, and we've got what appear to be lakes of something and seas. And so how do you get all of this? Well, methane is a gas here. Nice cold environment on Titan, guess what? It's liquid. And it's performing the same functions that water does on Earth. So it actually evaporates up into the cloud structures. It gets transported from one location to another the same way it would here. It rains hydrocarbons down on the ground. It runs down in channels and cuts grooves and rivers and everything, and then it pools up in lakes and seas. And this is a great image. This is one of my favorites, actually. It's a radar image. And the reason we took the radar, of course, is because you can't tell a scientist they can't see the surface of something, and Titan was not allowing us to do that any other way. So you take something like a radar and go in and have a good look. And I love this particular one. It's false colored. Most of them come back just in black and white.
Sure.
And what you're getting with a radar image is mostly how much light you get back from your signal. So you send a signal down, and whatever bounces back gives you information. But you have to determine what that means, because if you get less, does it mean that it's fractured and scattering the light, or is it being absorbed? So in the case of these lakes, it's actually being absorbed, which is why it comes back as dark. Anything that's in lighter is where you're getting a lot of return off of the radar, which is kind of cool. I worked for them for a while. There's a fascinating bunch of stuff. And here's our magic island. We had an island that was not there when we went through at one point, and it appeared and then it disappeared.
Atlantis.
Yeah. And what they think is going on is that we actually have a rise and a fall in the level of liquid methane. And so that it's like right near the surface and it disappears most of the time, and then the water level comes down and it comes up, and then it's...
That's pretty incredible.
Yeah.
That actually leads a little bit to another question, also from LBCG, which is, will we ever get a Titan rover mission?
Oh, that would be awesome, but just because we know that the probe survived for so long, it is possible for us to get something to survive for some time period on the surface. That would be really cool. I would suggest talking to somebody and saying, hey, why don't we?
Sure.
Because at this point, I don't think anybody's got plans for that. It would be awful nice. That one there, that image, that is one of my favorites. It's one of the first ones we got back, radar trace, that had the lakes in it. And they did the false color on it, and my first thought when I looked at it, and everybody had the same thought, we all looked at it at the same time and went, it looks like Minnesota. You know, land of 10,000
Don't you know, you betcha.
lakes.
Holy buckets.
Exactly.
Oh, jeez.
And so it's still one of my favorites because it's so darn pretty, even though they, technically it's not necessarily blue and brown land colored.
That's pretty much Minnesota.
Yeah. So I have relatives in Minnesota. This is part of the stuff that we were talking about. We have organic particles that are being generated. We have this goo that is being dropped all over everything. So what they're noticing is that some of the stuff goes up into the atmosphere, and you get your methane and your nitrogen, right? And you hit the energetic particles, create stuff as you go down, and the stuff just lands, and there's this hydrocarbon goo that's coating almost everything that's on the surface, which is one of the reasons we don't necessarily want to crash the spacecraft into Saturn into Titan at some point, because it's kind of a primordial Earth type setup. That image right there, that's from the Huygens probe when it landed. We got this image from the ground after it landed, and you can look, and it looks like any old riverbed, but you have to realize that all of those rocks, they're not stone, they're water.
They're water stone.
Water stones,
Yeah.
right.
Solid ice.
And we had there was a penetrator that was on the bottom of the probe, so when it landed, it kind of went in, and it took a second, and it punctured through. And they weren't quite sure what was going on, so it was a little bizarre, but what they determined later was that we had landed right after it had rained. And so we wound up with, it was in the process of evaporating at that particular point in time, and so the ground was like partially dry, wet underneath, right? It was kind of cool. The dunes, which we had shown up earlier, what happens with rocks when you grind them up a lot? You get sand.
Sure.
So that's basically what the dunes are. little bits of ice crystals. And we have enough wind, right? We got enough atmosphere, so it blows them around, and we wind up with these sand dunes, these huge sections of sand dunes. There we go. We call them cat scratches because that's what it looks like. But yeah, you can tell which direction the wind was blowing and actually follow them around. And there's some places where this is the dominant geology. So you have some places that are like this, you get some places that appear wet, you have places with mountains, and although we have not confirmed any yet, we think we may have cryovolcanoes. And I thought, okay, that's a weird topic, cryovolcanoes, what are you talking about? Think about it. On Earth, you melt rock and it flows out onto the surface. If you're in a cold environment and water is now your rock, you heat it up a little bit and it will flow like rock. And so you should have similar structures. And so we have a few candidates, but none of them have been specifically proven to be one or the other yet.
Will it flow like lava, like rock, or will it flow more like
slushy?
Water, like water,
it'd be slush.
Okay,
It'd be slushy, yeah.
Okay.
Yeah, that is the expectation anyway, yeah.
So we've been at Saturn. We've done incredible science.
Yes.
We've received iconic images.
Oh, yeah.
But now we're entering a period that you guys are calling the grand finale.
Yeah.
Tell me a little bit about said grand finale.
Well, again, this is one of those things where we decided to stay at Saturn because we were interested in looking at what was going on. And Enceladus, we still had some questions. We wanted to look at the rings in more detail, and we don't want to crash into Titan. We don't want to, but we knew that we wanted to look at these things in a little more detail. The problem is if we stay and we run out of fuel and we cannot control the spacecraft, gravity will take its course, and it may, in fact, run into one of these bodies that we don't want to contaminate. The spacecraft was not cleaned to planetary protection requirements because it's in orbit.
So it could have bacteria on it, which could
Yes.
do something
Yes.
bad to life that's already trying to start on one of these other surfaces,
Right.
or could create life from Earth, which
Right.
then we could misfind as...
Yes, right, and that would not be good. And you also don't want to take stuff in and actually take in a bug to something where you've got life that's there and ruin the existing life.
Sure.
So, and like I say, it's the project manager said, you can't go home, but you can't stay here. So at end of mission, while we can still control where we can point the spacecraft and we can still control its behavior, we decided to go ahead and crash it into Saturn. And the scientists said, hey, while we're thinking about doing that, we really need some data, like if we can go down in between, in that gap between Saturn's clouds and the D ring, the innermost ring. And so we figured out a way to do it. Our navigation guys worked out how to do it. And
I think you're looking at some of the...
here's some of the animations that have been drawn up.
I would call it an EDL, but it's more of like an ED. Entry, descent, landing, but there's no landing here.
There's no landing,
Yeah,
right.
It's more entry, descent, destruction.
Yeah, so we knew that we had to do that. So there's a number of things of information that we can get in that.
Wow.
Yeah.
You're, yep.
Yeah, well, the orbits are going to be on the order of a little less than a week, starting Thursday. It's the first
Well, you just performed.
Yeah,
One of the first,
we are right at the end of this. So the original plan was to do 20 orbits at just outside the F ring, which is the main portion of the ring system, and then shorten up the orbit and do 22 orbits in the gap between the D ring and the top of the atmosphere. So what we wound up doing, and I like this image because you can see what we did on Monday was set ourselves up for an encounter that we had this morning at 6-something a.m. Our time here in Pasadena, or well, we're in Anaheim, right?
Sure.
Somewhere in Southern California.
It's still 6 a.m. in
Still
Anaheim.
6 a.m.
Yep.
Time gets to be really difficult after a while. You try to deal with people overseas as well as
Coordinated
UTC
universal time for everything.
And spacecraft.
Oh yeah, you deal with spacecraft event time as well, don't you?
Yeah. So you have to know when something happened on the spacecraft because you're backing it out because you get a telemetry mode change or something, and you go, okay, is that the right time? And you do the math backwards and go, yep, that's when we commanded it. Okay.
They complain about us doing UTC. Imagine if we did things like, all right, figure out the show time based on the spacecraft event time of Cassini. Ready, go.
Yes, that would be yeah, it would drive you insane. And it's funny because when I was a kid, I used to take my, I'm going to date myself here, my LPs,
Yep.
my vinyl LPs, and rather than buy a cassette tape, because most of them were garbage and didn't last very long, you would go out and buy a higher quality cassette tape that you would tape, and so you would record your stuff on there. Well, nothing is ever the right length, so you wind up having to try to figure out how many minutes can I get on this side, right? So I have been doing time math my entire life, and I had no idea that I would be doing it for a living. Every single day, at least 2 or 3 times a day, I'm doing math going, okay, let's see if it happens on spacecraft, and I'm back to, let's see, we'll see it here. Okay, fine, then we can send, okay, then we have to wait this long to send the next command, and then we're going to get the, and so you're doing this math constantly, forward and back, and if somebody, we get a red alarm, okay, well, when did the alarm happen? Okay, back, okay, all right, what happened to this portion of the sequence? I mean, it's just, you're constantly doing math with time, and you get really good at it after a while, and I could do it on a piece of paper, nothing flat. But with regard to, where were we? We were talking about something. I forgot.
The grand finale.
The grand finale.
We're coming in.
Yeah.
We're going to crash into Saturn. And actually,
So,
really
yeah.
quick, a question comes from Johnny Space, I believe it is, which
Okay.
is, you're crashing into Saturn. Why not slingshot Cassini into deep space?
Because that would not allow us to get the data we're going to get towards end of mission.
And what is that data going to be?
One of the things we have not been able to do is determine the mass of the rings. Because at this point in time, we are orbiting the rings and Saturn. So we have it as a complete set. So in order to figure out which is which, you go down between. And then you can, I'm getting tugged this way, tugged that way. And it's important to figure out how much mass is there, because that'll give us an indication of how old the rings are. If I remember correctly, if there's a lot more mass and they've been there a very long time, if there's not as much mass, then they've been there for a shorter period of time. And so that's one of the things the scientists are looking for. 2, we're looking for the magnetic field and stuff in that region, and we're wanting to taste Saturn's atmosphere. So at the very end, the last 5 orbits, you'll see off to the right in the image, the last 5 before the red one that is our death knell. Those last 5 are actually close enough that we can taste the upper atmosphere with it. So we can actually get a little more, because we know that most of it is hydrogen and helium, but there's a little bit of some other stuff in there, and we know that it's there, but there's not a lot. And so one of the things we can do is actually go in and just taste it and say what's actually there.
So you're tasting this and you're sending this data back. Typically for some of these higher resolution images, you'll do something called store and forward. I assume you're doing store and forward.
Oh yeah, we have solid state recorders on board.
Right, so you're recording the image and then you very slowly send it back to Earth. But you're not going to be able to do that here, I assume, because...
Well, not on the last
parts where you're entering
right.
in, right? And you're smelling everything, and you're just going to spit that data out in real time as best you can?
Yes, yeah.
How fast is that going to be?
Well, I think we're supposed to be at about 142 kbits per second. Which I know sounds like hardly anything.
That's because it is, in fact, hardly anything. Yep.
Compared to Galileo's 5 to 7 bits, I'll take it.
Wow.
That was how fast they were sending data down after they lost their main antenna.
Huh.
It was less than 10 most of the time.
Wow.
So when we get those, at the beginning of the mission, we actually were getting 248 kbits, which was just screaming. That was great. But we got far enough out where the DSN antenna can't handle that rate for that distance.
Deep Space Network.
Yeah, Deep Space Network. Thank you. We're into the alphabet soup again.
Yeah.
Yes, it's lovely here in the canoe. The mission was designed to handle a certain amount uplink. Usually, I think we're at 500 bits uplink. But we've got several options. And then downlink, it depends on which antenna and where we're at. In the orbit that we're at the time that we're sending data down, and there's also issues about who else is trying to use the antennas, because as most of you know, we've got 3 antenna complexes around the globe, in Madrid, Spain, and Canberra, Australia, and out here in Goldstone, California, and there's multiple antennas at each site, but it doesn't always give you what you need. So if you're doing radio science, then they need certain equipment. So you have to try to get those antennas for this time period because we have to do this while we're occulting.
But you're
we
going
have to be, you know.
Come on, at that last
Yeah.
moment, the Deep Space Network is going to give you all the antennas, right? I mean, I have to
Actually,
imagine.
no. We haven't even finished negotiating those yet.
Oh, I have
for
to
the end
believe.
of mission. But we're gonna, yeah. But we have made some decisions because we've only got so many 70-meter antennas, right? So you have to make a decision. Do you want to try to go with the 34-meter antennas that you know you have multiples in multiple locations, so that you can handle the data rate regardless? So even if we get the 70-meter antenna, we're probably going to be at 34-meter rates. Yeah, and that's so that we can handle anything. So if something happens and we can't use the DSN antenna because something happens, a piece of equipment breaks, which happens occasionally, and we want to be able to handle the data rate.
Sure.
Regardless.
Because something's going to
Yeah.
happen to your spacecraft.
Yes, very, very much. Do you have the end of mission video? Don't? Rats, because that's really friggin' cool.
We'll guide. Oh, you know what? I did
one
totally
off-
forget to grab that. But we'll
Yeah.
guide people to that. Yeah.
Yeah, you can actually see it because what we're expecting to happen, since we don't have a lot of, we know we don't have a lot of oxygen there, so it's not actually going to burn. What it's actually going to do is melt. It's going to fall apart and melt. So what most of us are expecting is that it's going to start tearing pieces off of it.
Sure.
Initially, just from the force of the atmosphere as we're going through. So we expect pieces to come off and then the bits pretty much melt
That's going
on
to
the
be
way
incredible.
out. Yeah.
And when is that expected to happen? When,
That
when,
will
when do
be-
you expect to start melting Cassini?
That's at stupid o'clock in the morning.
It always is. I
Yeah.
don't know why. All the cool things happen at like some ungodly time.
Yeah, well, it's getting worse too because we got stuff going on this week that's going to be at stupid o'clock too. 4:30 in the morning, Pacific time.
Yep. All right. And
we're
that's negative.
expecting-
I believe that's -7 UTC.
Yeah,
Yep.
UTC if you're going to UTC. And then, of course, you have to back up about an hour and 15 minutes from there for the one-way light time. So by the time we actually hear about it, it'll have been over for an hour and a half. Which is, it's going to be a sad day. Trust me. We've all been working on this. Most of us have been working on this mission for so many years. It's going to be a sad day. But yeah, most of the stuff happens in the middle of the night. We actually hit, one year we hit all of the holidays, the major holidays between, I think, Labor Day and New Year's with a maneuver on those days. So we had people that actually had to be there to work for some reason or another, and all of them got hammered. So that was not a good year for families.
I do have.
But anyway, I was going to go back
ahead.
to what we're doing here. If you go back a couple of the videos, let's see, the one ball of yarn. Can you back up a couple more? Yeah, this is the ball of yarn. This is all of the orbits. I think this is the one that's all of the orbits for the entire mission. All in one big ball of yarn. And if you get to the next one, it'll cut them out, and you'll see just the ones from. This is from the Solstice mission, which is after equinox. So the ones in the middle, you see there's the yellow and the orange. The yellow ones are actually the F-ring orbits, and we have just finished our last F-ring orbit. And we did a maneuver on Monday that put us up to hit Titan at the right angle to change our orbit to start the first of the proximals. And that first proximal would be close proximity. That's where it comes from, the proximal orbit. Now here's the one now. So this is a great graphic because it shows you the last of the F-ring orbits. And this is the one that happened about a week ago. And then right in here, we did a little maneuver on Monday, and then you'll see Titan come in, and it will just bend our orbit, just tweak it just enough. And from here on out, we're basically ballistic. We have no choice. And so even if we couldn't do another maneuver, even if we don't survive this first ring plane crossing right there,
Which you may not. I mean, it's possible you'll hit something.
there's a possibility, yeah. I mean, the scientists have looked at it, and they've determined, they think they know what the safe region is. And if you go back to the one that shows you all of the
Well,
orbits.
we think we know is very different than we know.
Well, yeah.
Yeah.
But it's like, well, okay, fine. We did, we did radio subsystem stuff. We just checked stuff in there and where the stuff is. And so we know how much material's in there. How big they are, that's a little on the iffy side. But we believe that the section that we're going in is quite clear. It's about 1,800 kilometers wide is all. But our nav guys are good, so I'm not worried about it. Can you go forward a couple here? That one. Yeah, and this is like, you can see the rest of the orbits. This particular graphic is showing you how close Titan is to us. Now, we're not targeting Titan after this point, but it's still there, and it is still tweaking our orbit as we go by, so we're close enough that it's affecting us. So that's why we're getting, a little bit of progression, a little bit of change in the orbits. And if you go to the next one that shows the height, yeah, this one. You can see that we're not always in exactly the same place. And we do have, I was trying to find the other graphic and I couldn't. There's a line that goes across that's the safe zone. And those couple of high ones that you see off on the left, those are kind of in the danger zone, we think. We don't know. But we're hoping that we're okay there. But in order to make sure that we're all right, we're actually going to turn the spacecraft and do what we call a ram direction. So we're going to take advantage of our nice little antenna dish here and use it as a snowplow. That was, somebody put that image in my head several weeks ago, and I thought, yes, that's about right.
That's another Minnesota reference, 2 in one show.
There you go. We actually used the antenna early on in the mission. We were in the inner solar system because you notice that the bulk of the spacecraft is actually in the shadow of the antenna.
Sure.
These little shields down here were to shield the bits of the RTGs that stick out, the radiothermoisotopic generators. And so, but everything else, and this would have been, right, because we hadn't deployed it yet, it was under there. So we actually pointed the antenna at the sun for the whole inner solar system. And that was to make sure that we did not fry the bits of the spacecraft that are not really good at having heat on them. And when we get out, we're taking advantage of that again. So it's like, well, the mag boom, there's not a whole lot we can do. We can't, undeploy that at this point.
It's designed to go one direction, and that
one
was
way,
it.
that's it. But we're actually going to take advantage of that. So the first first plunge through, which is happening this Thursday, because we just did that Titan flyby this morning. And so it happens during the day on Wednesday. So, and we're not turning, we're taking data. So we're not actually turning to Earth until much later in the evening. So we won't find out if we're okay until about midnight Pacific time, when we're expecting to get the signal back. And we're having a little event at the lab for friends and family. So we'll all be there, and the Cassini virtual singers are going to be there and perform. And we're going to have a lot of folks talking about what we're doing and hopefully getting some images back, assuming that we've come through and we're okay. The project manager, Earl Mays, has said that we're expecting that everything's going to be fine. That's our best estimate, is that we think it's going to be fine. We could have a slightly bad day. Maybe we're in safing when we come out the other side. If we had a really, really bad day and the spacecraft is gone, I mean, that's, it's still a possibility. You never say never. But if that were to happen, we're already ballistic at that point. So we know that it doesn't matter anymore that we can't control the spacecraft. It's not going to hit Enceladus. It's not going to hit Titan. And it will crash into Saturn. We just won't get the data.
And you've had an incredible mission thus far.
Oh,
even if
yeah,
that happens, you've gone so far past.
Linda Spilker, our project scientist, she has said that we have completely rewritten the books on Saturn with this mission. And that's true. I mean, we knew some of the stuff from going in, but had no idea what we were going to find when we got there. Yeah.
All right. I have 2 more questions before we need to go to break. The first one actually comes from our own Space Mike, which is, what are you going to work on after Cassini? Are you going to do another mission?
Yes, I'm intending to. Because I'm working the last sequence, I've decided not to try to transition and do 2 jobs simultaneously, because as you know, when you try to do 2 tasks, everybody wants you full time. And the last thing I want to do is be the one that did something wrong and made this not do what we want it to do. So I've sort of told folks that I'm waiting to start to transition until this summer, after the sequence is completed. And so work on that is continuing now, and I don't know where I'll wind up. There's a number of missions that are working that at least 2 of them have asked for me. So we'll see where I wind up.
And the last is less of a question and more of a comment, which is basically the instructor said, I just noticed the Saturn and Cassini earrings. And we figured we'd point them out. I thought they were pretty cool.
Yeah, these come from quite a ways back. We've had an awful lot of people that have been inspired artistically for
They're
Saturn.
inspiring images.
Yeah, no doubt. I mean, I stare at them all the time. I got the best screensaver in the universe, is all the stuff from the mission. But there's actually, if you're interested, all these people that have done artwork based on the Cassini mission is on the website now. It's called Cassini Inspires, and you can go and look and see what artists have done all around the world that is inspired by the images and the mission itself. But these were done a number of years ago. Somebody had done, they're actually made out of paper, compressed paper, and they put the images on the top. And they used to sell them in pairs where you could get 2 spacecraft and 2 Saturns. And most of us just went out and bought 2 sets and then mixed them up. So I have 1 Saturn on one side and the spacecraft on the other. Yeah,
it's
cool.
It's an incredible mission.
Yeah.
Thank you so much for taking time out of your Saturday to come out here.
It's been an absolute pleasure. I love doing this. This has been a grand adventure. I never intended this to be, where I'd wind up. The people that I've met, the folks that I work with are some of the best scientists and engineers in the universe, and I wouldn't have traded a single second of it.
Your passion is infectious. Where can people go to watch the grand finale and see the ending parts of Cassini, or even go back and get some of these incredible images from Saturn?
The best thing would be to go to cassini.nasa.gov, G-O-V, and there's a gallery in there if you're looking for the images. There's text on there about the mission. Anything you want to know, it's on there someplace. We're actually up for a Webby Award.
All right.
Yep, because it's a nice website. Got these gorgeous pictures and all the new stuff. The brand new stuff comes up every day. So when we put new images up, it'll be one of the first things you see when you go to the website. And there's also a thing in there for raw images if you want to go and look through the raw images before they're cleaned up. A lot of folks do. We have a lot of people that are out there that are really fascinated with the mission, and they actually have taken some of our stuff and cleaned it up and done their own releases of some images where they've done the post-processing on it. So it's a lot of people are interested in it, and I seriously wouldn't trade it for the world.
Awesome. Thank you again so much for your time.
Appreciate it.
All right, we're going to take a quick break, and when we come back, comments from last week's show. Stay tuned. We'll be right back.
We've always looked to the stars. They guide us, give us comfort, help us find our way. We see ourselves out there. When we look up, it inspires us. And we long for something we don't yet know. We yearn to go there. So, we venture forth.
We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard. Because that goal will serve to organize and measure the best of our energies and skills.
Tranquility Base here. The Eagle has landed. It's one small step for man, one giant leap for mankind.
The exploration of space will go ahead, whether we join in it or not.
Many think we stopped exploring. But we know our journey didn't end.
T-minus 1 minute.
We've only just begun.
Orion engine is functioning perfectly at this point.
Come with us and explore tomorrow.
And welcome back to Tomorrow. Now, before we get started with comments from last week's show, a shout out to all of the patrons who have helped make this specific segment of this episode happen. These are the Escape Velocity members, easy for me to say. They've contributed $10 or more to this episode. We've also got our Orbital. These people have contributed $5 or more to this specific episode, and our Suborbital. These people have contributed $2.50 or more to this episode, and at Suborbital and above, you're going to get access to After Dark as soon as we make it available. For more information on how you can help crowdfund the shows of tomorrow, head on over to patreon.com/TMRO. That was an incredible interview. This is a very long show, and for those of you on iTunes, I'm sorry for the download time. All right.
That was an incredible interview.
That was, like I said, her enthusiasm is infectious. All right, Capcom, get me started with some comments from last week's show.
Great. So for those of you who are wondering, or in case you're curious, last show we were talking with Natalia Bailey, founder and CEO of Accretion Systems. So first comment comes off of Reddit, actually.
That was the Ion Drive.
Yeah,
the
tiny
tiny
Yeah, I
Ion
mean,
Drive.
I'd show you, but it's
incredible tech. Yep. Mm-hmm.
Yeah. The first comment comes off of Reddit from Arrow Spiked. Says, Spaceship 1 won the Ansari X Prize by flying above the Kármán line twice, but Spaceship 2 isn't going to go that high? No way. I don't want to answer the question, did you go to space with, well, sort of, after selling my house to afford the trip. I'd be laughing stock of Vagrant Alley. That's kind of a funny way of wording that. The first time I read that, I was like, of where? I don't know where that...
I get it, right? There's the line, and I understand. But it's also about the experience. You're still going to get to explore space. You're going to be in microgravity. You're going to float around the ship. You're going to be able to see the Earth. I'm not making excuses for them. I just think that saying, "Oh, I haven't been to space because I haven't crossed over this arbitrary line," which I realize is not arbitrary.
Right.
It's not. But saying that I haven't been there. It's like it's the same as how we decide to define a planet, right? Is Pluto a planet? Yes. No. I mean, it was, then it wasn't. Now it might be again.
I suppose.
But now that we're talking about making Pluto a planet, maybe our moon's a planet too. So it's all the same thing. Ignore the line. It's about the experience. That's my entire point.
And maybe a good example of that too is recently Adam Savage from Mythbusters did a flight in a U-2 spy plane and went up to, I believe it was 48,000 feet, and just the experience that he had from that height, which is nowhere near the Kármán line, was enough to have him have that spiritual experience that a lot of astronauts talk about.
The overview effect, absolutely. Yeah, if you can experience the overview effect,
right,
one might be able to argue, okay, you've made it into space, right? All right, next up. I mean, I get it, there's the line, there is the international, it doesn't matter. Anyhow, next up.
I still want the pin. Next comment comes off of YouTube. I mean, that's what we're saying, right? I want the swag. I'm all about the swag.
You don't necessarily need to go to space, you just want the swag.
No, I mean, I want the experience.
Can I go to space and give you the pin?
Okay,
I've been to space.
No. Next comment comes off of YouTube.
On everything.
I know, right? Comes from Atticland. Says, your analysis of NASA's plan just kind of ignores the elephant in the room. What if SpaceX's plan succeeds? Musk's Mars plan isn't affected by or based on government support, and especially as the Falcon rockets and others like it start to bring the cost down, makes the SLS, or Space Launch System, seem even more like a waste. No way that it'll fly politically or real world beyond 2020. Has NASA a plan for when, not if, the SLS gets scrapped? That's what I want to know.
Very interesting.
Those harsh words
so I guess
there.
that's referring to, of course, the news story I was talking about with all the new exploration missions.
Yeah.
And the reason I guess I was so excited about it is because of all of the different payloads that they were talking about.
Yeah.
And I feel that since the plan is in a fluid state right now, that if the space launch, or rather when, as this commenter says, the Space Launch System gets canceled, I feel like the longer it goes, the more opportunities they'll have for alternatives.
Sure.
And so with a lot of these newer rockets coming online, once Falcon Heavy comes online later this year, once the new Glenn rocket starts flying, once the ITS system starts flying, then they'll be able to send these payloads to interesting places. And maybe those payloads will get canceled. But I feel like since there actually is a plan now and we're going to move forward with this Lunar Gateway space station, that the different pieces of that can be sent up through either commercially or through something else that NASA does. But that's why I'm excited about it, because there actually is something. Like a year ago, if Space Launch System got canceled, then there wouldn't be much of a plan. But now that there are all these different pieces of hardware that they want to launch, they can do that with other things. Sorry to ramble there for
I
a
feel
moment
like you're
there.
apologizing for getting
You're absolutely right. I feel like that was a point that I missed.
I feel like you're apologizing for getting excited about something, and you shouldn't. I mean, this is exciting stuff.
It is exciting, but and I don't want to discount. I mean, I totally agree with what you're saying. Don't get me wrong, Mike. I think one of I'm somewhere in the middle. I sort of agree with this commenter, though, to a certain extent, because it's like, sure. You can make all the plans you want in the world. I want to be a famous actress and live in Paris. But if I don't, that's not going to happen.
Sure.
You know what I'm saying? So there's some sort of middle ground there of...
But we don't know what's going to happen with SLS.
Right, and that's
I think
part
the
of
other gripe
problem.
is some of those missions were like at 2060 and whatnot. So anything beyond, when it comes to NASA, anything beyond 8 years, you can just ignore it.
Pretty much, which is really unfortunate. But that's the thing. Like, you can make all the plans you want in the whole universe, but it may or may not make any difference. But it is good that they have something in the forefront of their minds in general, right?
And I guess that's why I was so excited about this, because there wasn't really a plan for the next 8 years.
Right.
Like, we had a plan for like the next 4 years, but there wasn't really much of an actual detailed plan to get us to this whole path to Mars in the 20s, 30s. And that's why I'm excited about this. This is laying out a very detailed plan, which I had too much detail and we glossed over, of what we're going to be doing in the 2020s to try to reach that goal. So.
Yeah.
All right. Next
I
up,
feel like the rocket could be almost any rocket, and you might have to split the pieces up and have some creative design there. But these goals can still be accomplished with a lot of the different rockets that are either available now or will be coming online in the future.
There are certainly advantages to flying out on something like Space Launch System, where you don't have to split it up, right? I mean, you look at Skylab versus International Space Station. Similar usable volumes. One went up in one launch. The other one took a lot of time and money. So.
Oy. Yeah. All right. So next comment comes off of Twitter from Daniel.
I just realized I said it was similar usable volume. I'm not actually sure that's a true statement. So, Internet, correct me if I was wrong there.
Star, and I know you will.
All right.
Daniel says, awesomely miniaturized tech, but it's pretty power hungry compared to things like CAT or Constant Q at about a quarter thrust / power. Better SI though.
It's engineering trade-offs.
Sure.
Right. So
right.
it depends on it depends on what you need it to do, and sometimes more power isn't a big deal, and that's okay. Sometimes it is a big deal,
right.
And that's not okay. So all depends on the application in which it will be operating. I think you use different engines in different scenarios, and having more options is not a bad thing.
Sure. Yeah. All right. Cool. Next comment comes off of YouTube. I did not read the name on this one. Aristides Lycus, right? Is that
sure.
Yeah? All right. Axion's technology is very interesting, with the ability to prove an increase in velocity, delta V for us nerds, of 1,000 meters per second. That would be ideal for slowly ferrying payloads from low Earth orbit, or LEO, to almost escape velocity from Earth.
Yeah, you could use it for something like an Aldrin cycler.
Yeah.
Right? Which is where you basically got a spaceship or station that basically goes between Earth and Mars, but never lands. It just cycles and goes back and forth. You wouldn't necessarily, I believe the idea behind the Aldrin cycler is that you're using the gravity assists of both planetary bodies to kind of keep your momentum and whatnot, but you're still going to need to use it for course corrections, and sometimes you may even need to slow down so you can have visiting spacecraft, like a space shuttle of sorts, visit said cycler. And so something like this would be very cool for something like that. Or even for, if they get to those theoretical maximums, which again, those are theoretical maximums, who knows? If they can get to that level, it might even be cool for just, payloads in general. I think the coolest and most exciting part of it is for CubeSats. Right? You look at propulsion for CubeSats, and there just are not a lot of options today. This could be a potential game changer for small sats and CubeSats.
Yeah, that would be really cool. Really, really cool.
Absolutely.
Next comment comes off of YouTube from Ravener. I'm skeptical of the ion drive. Bringing ions in solution seems like a very heavy way to store ions, meaning you lose the efficiency we used it for to begin with.
Yeah, I mean, again, it's all an engineering trade, right? So you have to, what is the equivalent? Energy is 0.5 mass multiplied by velocity squared. So yeah, the mass of the propellant matters, as does the mass of what you're moving, but if you can move it very quickly out of the back of the unit, then it's the velocity squared, so you actually get quite a bit more oomph, I guess I'll use.
Right.
Yeah, it is potentially heavy, but it's also what am I trying to say? Densified, like you can get a good chunk of energy out of it.
Yeah, the propellant for ion drives is extremely less than traditional propellant, even in something toxic propellant or a cryogenic propellant. So yes, there is that weight there. I mean, it's not a EM drive that has no fuel whatsoever,
Right.
but the amount of weight for that fuel is minimal compared to traditional rockets. Is that what you're trying to say?
Yeah, basically. Yeah. I mean, again, it's engineering trades, right? So sure, use something else, but what are you trading for that, right? I mean, there's a pro and a con to everything, and having more options is a good thing. That's all I'm saying. Yeah, it may not, like, I'm not going to use this to try to get out of Earth's gravity well.
Right.
That's not an appropriate application for this. Also, I'm not going to try to use an F1 engine from a Saturn V sea level in the middle of space to try to do station keeping for the space station.
No?
No, I'm not going to do that. That seems like a terrible use of an engine. Imagine the weight. Oh my
What
God.
about for a coffee table?
Maybe for a coffie table.
Okay,
You
sure.
just kind of gotta. Let me get my coffee. I think I can. All right.
Just checking.
Last comment.
Last comment.
I exerted myself on that comment.
Yeah. Careful. Last comment comes off of Patreon from a Miss Sarah Hill. That hat is going to stink up the set and attract various insects, which will nest in it and spawn more insects.
You know, I didn't think. Did you grab a picture of the hat that we could bring? I don't. I just now thought of that. That was from last week's. Was that After Dark? Was that in the show? That was in After Dark. Phase 1 of the observation lounge is complete, and with that, we have retired Dada's horribly MDF'd hat.
It was so caked with MDF. It's a black hat, and it looked like light brown.
Like brown. It's just gross.
Which is hilarious though, because
it is bonded with the hat.
Today he's wearing a lovely orange Jungle Cruise hat. That looks so bizarre to me on him. It's a weird thing.
And also, I've been wearing that hat for the better part of 2 years.
Yeah,
it was time to retire it.
It's gross.
And that is where it goes. And there are some neat things about the set that you don't normally get to see, the hat being one of them.
Yes.
One other thing that you don't normally get to see is any guest that shows up in studio actually gets to sign the set as well.
Yeah.
So we've got a panel on the side where guests have signed, and it's pretty cool.
It is pretty
All right, that's our show. I wanted to thank all of our ground support patrons as well for helping to contribute to the show. These people who contribute $1 up to $2.49, and they're going to get access to our Hangouts and a bunch of cool things on the Patreon channel. Again, if you want to help crowdfund these shows, we couldn't do this without every one of you. Head on over to patreon.com/TMRO. Next week, Michael Mealing with the Waypaver Foundation. They're working on solutions for getting humans to the moon. So they're trying to find the problems that are holding us back and solve them. I think that's going to be a really, really interesting show.
And for those of you who've been watching for a while, that name might be familiar. Interesting.
Might bring that up.
So there.
Thank you all for watching. After Dark is up next. See you next week.